Welcome to section 11.1, Angle Measures in Polygons. The objective for this section is to find the measures of interior and exterior angles of a polygon. So in previous sections we've looked at the sum of the measures of interior angles of different polygons, such as triangles and rectangles. But what we generally want to think about now is the fact that the sum of the measures of the interior angles of a polygon, it depends on the number of sides. So the sum of the measures for a 5-shaped polygon will be different than the sum of the measures for a 6-shaped polygon. So there is a correlation between the number of sides of a polygon and the sum of measures of the interior angles. So for example, if we look at a triangle, we all know that a triangle has 180 degrees in the interior. It has 3 sides. There's one triangle inside a triangle technically, so sum of the measures of the interior angles is 180. But now if you looked at a quadrilateral, for example, let's look at this rhombus. In this rhombus, there are technically 2 triangles. So the sum of the measures of the interior angle is 2 times how many angles there are in a triangle, which is 180. And if we keep going for all these shapes, we'll see the same correlation. If we look at a pentagon we know has 5 sides. And if we draw diagonals, we see there's 1, 2, 3 triangles. So there are 3 triangles, so as you can guess, the sum of the measures of the interior angles is 3 times 180 degrees. Now we can summarize all of this in the rule that we're going to learn about, the sum of the interior angles of polygons. And the sum of the interior angles theorem tells us that the sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180. Now the correlated theorem 11.1 asks us to find the measure of each interior angle of a regular n-gon. Now we have to really remember what the term regular means. Regular means that it is equilateral and equiangular. So make sure you guys pause and take these formulas down because we'll be using them in the rest of this lesson. So let's use the formula to find the sum of the interior angles here so we can figure out what x is going to be. So we know that our formula is n minus 2 times 180 gives us the sum of the interior angles. So what we want to do is we want to figure out what all these angles together should add up to so we can subtract that value to figure out what x is. So first we have to count the sides. So here's 1 side, 2 side. We have to be careful down here at the bottom because technically there's 3, 4, there's 5 sides to this shape. It kind of bends right here at the bottom, so that's why that 3 and 4 are there. So there's 5 sides to the shape, so when we plug that into our formula, we have 5 minus 2 times 180 equals 3 times 180, which equals 540 degrees. So we figured out the total of what's happening inside of the polygon. Now we have to figure out what x is. So to do that, we need to add up all these values and equal them to 540. So we would add up 115 plus 96 plus 90, remember this is a right angle, plus x plus 64 equals 540. So when we add up the left side, we have x plus 365 equals 540. We subtract 365 from both sides, and we get x equals 175 degrees. So, similar practice problem here. We want to figure out what the value of x is. So first thing we want to do is count the sides. So there's 1, 2, 3, 4, 5, 6 sides. So our equation of n minus 2 times 180, we're going to figure out the sum of the interior angles of this polygon are going to be 4 times 180. So two 360s, which give us a total of 720 degrees. So same idea. Now we need to add up all these values and equal them to 720. So your equation is going to say x plus 120 plus 90 plus 135 plus 135 plus 90 equals 720. So when we add up all these values, we get x plus 570 equals 720. We subtract 570 from both sides, and we get x equals 150 degrees. In the previous two examples, I've shown you a picture and we've figured out what the sum of each interior angle is. Now we're going to look at a regular polygon and figure out how many sides a polygon have if we know the measure of each interior angle. Remember, regular means all the angles are going to be congruent. So this is the second formula that we learned in this section, which is the corollary to theorem 11.1, which says that n minus 2 times 180 divided by n equals the measure of each interior angle. So we know that the measure of each interior angle is 144. So we want to figure out how many sides the polygon has. So how many sides is going to be the variable n. So what we need to do here is we need to plug in 144 on the right side of this equation. So when we do the math, what we're really going to have is 180n minus 360 times 144. Now realize that I'm not going to divide the left side by n. What I'm going to do is I'm going to multiply both sides by n. So that would effectively take this one out of the denominator on the left side and leave me with my n over here. So from this point, I want to get all the variables on one side. So I subtract 144 from both sides. And what I have is 36n, I'm going to move the 360 to the other side, equals 360. So here, if I divide both sides by 36, I'll see that n has to equal 10. So if you got lost on this step here, just remember, instead of keeping my n at the bottom, what I did was I multiplied both sides by n, so I can end up with my n right here. So I want to transition from interior angles to exterior angles. So the way that we get exterior angles is if we had, first step is to shade one exterior angle at each vertex. So we stretch out all the sides and shade one of the exterior angles. Now the reason we're doing this is because we want to figure out what's the correlation between the exterior angles and the interior angles. So if we were to cut out all the exterior angles and put them in a circle, we'll see that the sum of the interior angles has to be 360. And that leads us into our next theorem of 11.2, which says the sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360. So we know that if we add up all the exterior angles of a polygon, it's going to be 360 degrees. Now the corollary to theorem 11.2 says the measure of each exterior angle of, once again, a regular n-gon is 1 over n times 360, or 360 over n. So now we're given this diagram with these exterior angles, and we want to figure out is what the value of x is. So we're given all of the exterior angles except one. So we have to be careful because we recognize that this line here extends, we're given this angle. This line extends here, we're given that angle. This line extends to this point, we're given this angle. But the only thing we're not given is this 90, so we can't leave that out of the equation. So we know that the sum of the exterior angles of a polygon is 360 degrees. So once again, we're going to add up all of our exterior angles, x plus 90 plus 2x plus 70 plus 80 plus 60, and we're going to equal them to 360 degrees. So here we combine like terms, and we have 3x plus 90 plus 70 plus 80 equals 300. Then we subtract 300 from both sides. We have 3x equals 60, so x has to equal 20. Now in this example we're shown a regular pentagon. Remember, we know it's regular because all the sides are equilateral and all the angles are the same. So to find the measure of each exterior angle of a regular n-gon, we use the equation 360 divided by n. N is the number of sides. It's a pentagon, there's 5 sides, so it's 360 divided by 5, which equals 72 degrees. So now let's look at this home plate marker. In softball, these happen to be pentagons. 3 of the interior angles of the pentagons are right angles, and the remaining 2 interior angles are congruent. We have to figure out the measure of each angle. So what we want to do now is, we know what angle A, B, and D are going to be. Those are all 90-degree angles. But we have to figure out what E and C are. So let's give those the variables of x and x, since they are congruent. So our plan should be to figure out what all of the angles inside of the home plate marker are, and then figure out what x and x are. So we have to use our equation n minus 2 times 180 because we want to find the sum of the interior angles. Now it's a polygon, so there's 5 sides. So 5 minus 2 is 3, and multiply that by 180. When we do that, we end up with 540 degrees. So all these angles inside of here have to add up to 540 degrees. So let's write our equation. We know angle A is 90, angle B is 90, angle C is x, angle D is 90, and angle E is x. And all of these have to add up to 540. So we add up the 3 90s, we add up with 270 plus 2x equals 540. Now we subtract 270 from both sides, and I'm just going to write this up here. So we're going to have 2x equals 270. Then we divide both sides by 2. We have x equals 135 degrees. So angle E and angle C equal 135 degrees. And that is the end of our video for 11.1. Here is the classroom assignment for tomorrow. Don't do it now, but you can write it down now. But once again, thank you, and I hope this was helpful. Alright, take care.